Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Yeah, hi, all. Good evening. I've shared my screen. Is it visible? Is my screen
Yes,
visible,
ma'am.
children? Yeah. All right. So I already have the answers to the assignment I shared on squares and square roots as well as cubes and cube roots. I'll share the images on WhatsApp by the end of this class or maybe after the class today. All right. So you can check your answers. So this is the next chapter, understanding quadrilaterals. We'll see the introduction to this chapter now. All of you, please acknowledge my screen is visible, right? All of you?
Yes, ma'am.
Yes, ma'am.
Okay. All right. Fine. So first of all, what is a quadrilateral? So a quadrilateral is a polygon. Now, what is a polygon? What is a polygon? A polygon is a closed figure. Is a closed figure made up of line segments or bounded by line segments. A polygon is a closed figure bounded. Bounded meaning made up of. Okay, made of or made up of line segments, bounded by line segments. Line segments. Now, this figure is made up of line segments. This figure is made up of line segments. 1, 2, 3, 4 line segments, but it is not closed. So it is not a polygon. There are two conditions needed to be satisfied for a figure to be called a polygon. It should be a closed figure. Also, it should be made up of only line segments. So it should be closed as well as made up of line segments. So when you see this figure, 1, 2, 3, 4. So you can see this figure is made up of 4 line segments, but it is not closed. It is not closed. Hence, this one is not a polygon. This is not a polygon because it is not a closed figure. Now consider this one. Okay. So this figure is closed. You can see like, okay, 1, 2, 3 sides or 3 line segments. This figure is made up of 3 line segments. 1, 2, 3 line segments. Now this one on top is not a line segment. It's a curve. It's a semicircle, in fact. It's a semicircle, and a semicircle is not a line segment. It's a semicircle. It's not a line segment. So this figure is closed, but is not completely made of line segments. 1, 2, 3, 3 line segments. And on top is a semicircle. So this figure is closed, but is not completely made of line segments or is not made of line segments only. Hence, this one also is not a polygon. So a triangle is a polygon. A triangle is a polygon because a triangle is a closed figure and it is made up of line segments. And a triangle has 3 line segments. Similarly, a quadrilateral. A quadrilateral is a closed figure. A quadrilateral is a closed figure. And it is made up of line segments only. It's made up of line segments only. So a quadrilateral is a polygon. It's a polygon because it's a closed figure and also because it's made up of line segments only. So a quadrilateral is a polygon is a polygon formed. So when you read this word polygon, you must understand that it's a closed figure made up of line segments only. So a quadrilateral is a polygon formed by joining 4 points in a plane in order of which no 3 points are collinear. Let's understand what this means. So let's take 4 points. Let us take 4 points, random 4 points. All right. Now, it's formed by joining 4 points in a plane in order of which no 3 points are collinear. All right. Now, joining in order means you should not join the points like this. Joining in order, that means you should not join it like this. You must not lift your hand while joining. See here, when you join these 2 dots, you have to lift your hand and then join these 2 dots. So we are not making any rangoli pattern here. We have to join the 4 dots. We'll have to join the 4 dots in order, meaning without lifting the pen or pencil from the paper. So it goes like this. So you start like this. See here, you should not lift the writing instrument. You must not lift the writing instrument. Keep going till you finish the figure. Yeah, see here. So a quadrilateral is a polygon formed by joining 4 points in a plane in order. In order, that is without lifting. In order. So we got a quadrilateral. So we took 4 points and we joined the 4 points in order, and we can see a quadrilateral being formed here. But what's the condition? No 3 points must be collinear. Because if you have of the 4 points, if 3 points are placed like this, collinear points are points that can be connected by the same straight line. Collinear. Collinear meaning, I'm just splitting it up for you. Collinear spells like this. Collinear is this one. The double L in collinear. Collinear meaning, can you see the word line here? So like you say co-passenger. Co-passenger. The passenger or passengers traveling with you in the same bus or train. Co-passenger, collinear. Collinear meaning 3 or more points lying on the same straight line. When 3 or more than 3 points lie on the same straight line, then the points are said to be collinear. So of the 4 points, no 3 points must be collinear. So if 3 points are collinear, what happens here? Then they can be connected by the same straight line. Then the figure obtained by joining the 4 points is not a quadrilateral but a triangle. Of the 4 points, if 3 points are collinear, that is if they lie on the same straight line, and say 1 point is away. Okay, so of the 4 points, 3 points can be connected by the same straight line. Then by joining the 4 points, you cannot get a quadrilateral, but you get a triangle. So that's why that condition, no 3 points must be collinear. 2 points are always collinear. See, the term collinear is used for 3 or more than 3 points. It's not applicable for 2 points because 2 points can always be connected by a line. 2 points can always be connected by a line. So we cannot say that these 2 points are collinear. 2 points can always be connected by the same straight line. The term collinear applies to 3 points or more than 3 points. So 2 points will always, will always lie on the same line. So 2 points can be like this. The third one should not be the continuation here like this. It should be away and away somewhere like this. The third point away and the fourth point also somewhere else. Then you can join and get a quadrilateral. That's a definition of a quadrilateral. A quadrilateral is a polygon formed by joining 4 points in a plane. Plane meaning a plane surface. Any flat surface is a plane. In a plane, in order, you should join in order, of which no 3 points are collinear. Now look at this quadrilateral. So here you can see the quadrilateral called ABCD. And you should also name the, the vertices in order. See, you cannot A, B, you cannot mark C here and D here. If you do this, then your quadrilateral is ABDC. It's not ABCD. You cannot mark it like this and call it ABCD. It is ABDC. So when you name the quadrilateral, also you go in the clockwise or anti-clockwise direction. You cannot randomly pick the points and you cannot call this A, C, D, B. Not like that. So how do you name the quadrilateral? After you mark the vertices like this, how do you name it? Go in a specific order. A, B, C, D. Or you can call it A, D, C, B. But not, you cannot call this A, B, D, C. So if you call your quadrilateral ABCD, then you have to mark it like this, or if you mark A here and B here, A, B, you have to mark C here and then D here. So go in the clockwise or anti-clockwise direction. So here you see this quadrilateral ABCD, and we have also connected the opposite vertices A and C, B and D to get the diagonals. To get the diagonals, we have connected the opposite vertices A and C, B and D. So you can see the quadrilateral with 4 sides and its 2 diagonals. Okay. So let's get familiar with these keywords. In a quadrilateral ABCD, or you can say in the quadrilateral because it's above here, in the quadrilateral ABCD, the points A, B, C, and D. This is a point A, point B, point C, point D are called as vertices. Angle A, angle B, angle C, and angle D. So this is angle A. So like this is angle A, this is angle B, this is angle C, this is angle D. They're called as interior angles. This is the symbol for line segment. Line segment AB, line segment BC, line segment CD, and line segment AD are its sides. AB, BC, CD, AD or DA are its sides, and AC and BD are its diagonals. So a quadrilateral has 4 vertices, 4 interior angles, 4 sides, and 2 diagonals. Now, AB and CD are called opposite sides. Opposite sides. Similarly, BC and AD, opposite sides. AB and CD, opposite sides. BC and AD, opposite sides. See, the sides are, when you name the sides in order, they are AB, BC, CD, and AD. When you name it in order, AB, BC, CD, and AD are the sides in order. So the next will be the adjacent sides, like AB and BC are adjacent sides. Okay. AB and BC are adjacent sides. BC and CD are adjacent sides. CD and AD adjacent sides. See, when we say adjacent sides, you will take only 2 sides at a time. When you say adjacent sides, you have to take only 2 at a time. AB and BC are adjacent sides. BC and CD adjacent sides. CD and AD adjacent sides. AD and AB adjacent sides. You can write AB again. You can write that AB again. This one, AB again. So AD and AB are adjacent sides. Opposite sides, AB and CD are opposite sides. BC and AD are opposite sides. Again, angles. Angle A and angle B, adjacent angles. Angle B and angle C, adjacent angles. Angle C and angle D, adjacent angles. Angle D and angle A, adjacent angles that lie next to one another. An angle just next to an angle. So next to A, angle B, angle A and angle B, adjacent angles. Angle B and angle C, adjacent angles. Angle C and angle D, adjacent angles. Angle D and angle A, adjacent angles. Opposite angles. Angle A and angle C, opposite angles. Angle B and angle D, opposite angles. So if you have to mention the pairs of, if you have to mention the pairs of opposite angles, angle A and angle C is one pair, and the other pair, angle B and angle D. So we have adjacent sides, pairs of adjacent sides, only two. Pairs of adjacent sides, pairs of opposite sides, pairs of adjacent angles, and pairs of opposite angles. So vertices, angles, sides, diagonals. Now for angles and sides, we have adjacent sides, opposite sides. Adjacent angles, opposite angles. So here, angle A, I'm repeating, angle A and angle B are a pair of adjacent angles. Angle B and angle C are a pair of adjacent angles. Angle C and angle D are a pair of adjacent angles. Angle D and angle A are also a pair of adjacent angles. If you continue, we'll come back again to the first one, angle A and angle B, pair of adjacent angles. Opposite angles, angle A and angle C, one pair of opposite angles. Angle B and angle D, another pair of opposite angles. So when at sides, AB and BC, adjacent sides, they're not equal. I'm just marking it like that. They're not equal. They need not be equal. They may be, but they need not be. So this one and this one, adjacent sides, this one and this one, adjacent sides, this and this adjacent sides, this and this adjacent sides. When you say adjacent sides, take only two at a time. You cannot say all the four sides are adjacent. Take only two at a time. So if you mark like this angle and I'm sorry, this side and this side, yeah, they are adjacent sides because CD, DA, adjacent sides. Adjacent sides will share a common vertex. You can see that CD and DA, they have a common vertex. Adjacent sides will share a common vertex or will have a common vertex like CD and DA. They have a common vertex D. If you say AB and BC, they have a common vertex B. While opposite sides will not have a common vertex. Now AB and CD are opposite sides and you see that they don't have any common vertex because the vertices are A, B, C and D are the vertices. Opposite sides AB and CD do not have any vertex in common. Opposite sides do not have a vertex in common, while adjacent sides will have one vertex in common. So that's about the parts of a quadrilateral. Now next, types of quadrilaterals. Types of quadrilaterals. So quadrilaterals are classified based on the based on parallel sides. Okay, so quadrilateral has four sides or two pairs. Four sides meaning two pairs of sides or two pairs of opposite sides. Two pairs of opposite sides. All right. A quadrilateral has four sides or it has two pairs of opposite sides. Okay. So when no pair of opposite sides are parallel, when no pair of opposite sides are parallel, then the quadrilateral is called a kite. A kite is a quadrilateral in which no pair of opposite sides are parallel. A kite is a quadrilateral in which no pair of opposite sides are parallel. Trapezium. Trapezium. A quadrilateral in which exactly one pair of opposite sides is parallel. Exactly one pair. If in a quadrilateral, one pair of opposite sides is parallel, then the quadrilateral is a trapezium. Parallelogram. Parallelogram. A quadrilateral in which both the pairs of opposite sides are parallel. There are only two pairs of opposite sides. There are four sides and two pairs of opposite sides. One pair, two pairs. Two pairs of opposite sides. So if no pair is parallel, it's a kite. If one pair of opposite sides parallel, trapezium. Both pairs of opposite sides parallel, it's a parallelogram. Now trapezium, we have scalene trapezium, isosceles trapezium, and right trapezium. Right trapezium. Trapezium, we have scalene trapezium, isosceles trapezium, right trapezium. And parallelograms, we have rhombus, rectangle, and square. Kite has no further, kite is not further classified. So these are the different types of trapeziums. Scalene, isosceles, right. Parallelogram, three types: rhombus, rectangle, square. Every rhombus is a parallelogram because these are the three types of parallelograms. Rhombus, rectangle, and square are the three types of parallelograms. Every rhombus is a parallelogram. Every rectangle is a parallelogram. This is like the parent, the parent figure. This is like a parent. So every rhombus is a parallelogram. Every rectangle is a parallelogram. Every square is a parallelogram. But every parallelogram need not be a rhombus or a rectangle or a square. It can be just a parallelogram. So these are the special types of a parallelogram. Rhombus, rectangle, and square are the three special types of a parallelogram. Rhombus is a parallelogram, true. Rectangle is a parallelogram, true. Square is a parallelogram, true. Now the reason why, because the definition of a parallelogram is that both the pairs of opposite sides must be parallel. Any quadrilateral satisfying the definition of a parallelogram, both pairs of opposite sides parallel, is the definition or is the condition for a quadrilateral to qualify to be a parallelogram. So when you take a rhombus, you will see that both the pairs of opposite sides are parallel. Then why is it called a rhombus? Because it has some more properties. Beyond a parallelogram, it has further more properties. So if you take a rhombus, rectangle, or a square, both the pairs of opposite sides will be parallel. That is why they are parallelograms. They have special names because they have further special qualities or features or properties. Okay. So no pair of opposite sides parallel, kite. A quadrilateral in which no pair of opposite sides is parallel, it's a kite. One pair of opposite sides parallel, trapezium. Both pairs of opposite sides parallel, parallelogram. Types of trapezium: scalene, isosceles, right. Types of parallelograms: rhombus, rectangle, square. that's what you see in this slide, children. So class, use the emoji, raise your hand. Use the raise hand option and raise your hand, class. Ishwarya, Shivam, Lakshana, Shreya, Yarni, Harsha. Harsha, you were not there, I think, in the last class or last two classes, right, Harsha? Last class? You didn't miss any class recently, Harsha?
No, ma'am.
Okay. Gayatri, Surya, Anantika. Anantika and Sai Smriti, are you there?
Yes, ma'am.
Okay. All right, children. So what we just understood is what you see in this presentation. Kite, no pair of opposite sides parallel. Trapezium, one pair. And types of trapezium, scalene, isosceles, right. Parallelogram, both the pairs of opposite sides are parallel. Types, rhombus, rectangle, square. Now we'll see the details of a kite. That is the properties of a kite. So we know that a kite is a quadrilateral in which no pair of opposite sides are parallel. But what are the further special properties of a kite? So in a kite, both the pairs of adjacent sides will be of equal length. Both the pairs of adjacent sides. So see here, this side and this side, they're adjacent sides. They'll have the same length. This one and this one, adjacent sides, they'll have the same length. So a kite is a quadrilateral. So the properties of a kite, two pairs of adjacent sides will be of equal length. So if I call this ABCD, AB is in this figure, AB is equal to AD. Also, BC is equal to CD. So here, a kite is a quadrilateral that has two pairs of equal. This is, see now, no pair of opposite sides parallel is one thing. These are the properties of a kite. A kite is a quadrilateral that has two pairs of equal length sides. Two pairs of equal length sides, and these sides are adjacent to each other. It has two pairs of equal length sides, and these sides are adjacent to each other. Opposite sides equal, no. Adjacent sides equal, not opposite sides. Next sides, adjacent sides. It has two pairs of equal length, and these two pairs are adjacent sides, pairs of adjacent sides. Okay. Now, the two angles are equal where the unequal sides meet. Now, where do the unequal sides meet? This one and this one. These are the unequal sides. These two are the unequal sides. This one and this one. These two are the unequal sides. Unequal meaning not equal sides. These two sides are not equal. Which side? This side and this side. Not equal. In this figure, this one is shorter than this. Here also, this side and this side. Where do they meet? These two sides meet at A and these two sides meet at B. These two angles will be equal. These two angles are equal. These two angles. So in this figure, angle A is equal to angle B. Now, this triangle, if you look at the kite as a summation of two triangles, if you look at the kite as a summation of two triangles with a common base DC, okay, if you look at the kite as a figure made up of two triangles with common base DC, see, one triangle like this and another triangle here. These two triangles are identical. Ignore this line in the middle. Okay, see, we're talking only about these two triangles. We're talking about these two triangles, so ignore this one in the middle. Ignore this. So I'm like talking about this triangle and this triangle. These two triangles. They are identical triangles. They are identical triangles. Congruent triangles meaning they're identical triangles. Like if you try to place one over the other, they'll coincide. When you place them in a particular way, when you place the triangles one over the other in a particular way, they'll coincide. Identical things will coincide, right? So these two triangles are congruent to each other, meaning they're identical triangles. When you look at the figure as a summation of two triangles with the longer diagonal as a common base. If you take the longer diagonal as a common base and look at this triangle, this one as a triangle and this one as a triangle, these two triangles are congruent triangles. They're identical triangles. Then talking about the diagonals, AB is one diagonal, BC is the other diagonal. Sorry, I've named it A. Let me change it. Let me just change this. Yeah. So AC is a diagonal, BD is the other diagonal. AC is a diagonal, BD is the other diagonal. The diagonals are not equal. The diagonals will not have the same length. In a kite, diagonals are unequal. And the diagonals are perpendicular to each other. They meet at right angles. The diagonals, they meet at right angles. That means they're perpendicular to each other. Where they meet, they make a right angle. This is one diagonal. This is the other diagonal. Where they meet, they may make a right angle. Here also it's 90. Here also it will be 90. Here also 90. Because if this is 90, this also will be 90. Linear pair. Vertically opposite angles, 90. Vertically opposite angles, 90. So diagonals intersect at right angles. The longer or the main diagonal, the longer diagonal is called the main diagonal that bisects the other diagonal. The longer diagonal, that is the longer diagonal cuts the smaller diagonal into two equal pieces. Bisection, bisect, trisect. Bisect is two equal halves. The longer diagonal cuts the smaller diagonal into two equal pieces. So the longer diagonal bisects the smaller diagonal. The longer or the main diagonal. The longer diagonal is also called the main diagonal that bisects the other diagonal, the smaller diagonal. A kite is symmetrical about its main or the long diagonal. That's what we understood. It's symmetrical meaning the two pieces on either sides of the longer diagonal, they are identical. They're identical. This is the longer diagonal. This is the longer diagonal. These two triangles, they're identical. The shorter diagonal divides the kite into two isosceles triangles. Yeah, because we know that these two sides are equal. So that means when you consider this triangle, this is an isosceles triangle. Again, these two sides are equal. These two sides are equal. So when you consider this triangle, this is an isosceles triangle. Because these two sides are equal. So this is the smaller diagonal. AB is a smaller or the shorter diagonal. AB is a shorter diagonal. So if you take that as the base, if you take the shorter diagonal as the base and consider the two triangles, ADB and ACB, they are two isosceles triangles. Because this side is equal to this side is equal to this side. Yeah. So I hope we understood. Let's do it again. The two angles are equal where the unequal sides meet. This one and this one, these two adjacent sides are unequal. These two adjacent sides are unequal. Where they meet here at A. This angle is equal to, again, these are two adjacent sides which are unequal. These are two adjacent sides that are unequal. They meet here at C. These two angles are equal. These two angles are equal. Then when you take the longer diagonal BD, these two triangles are identical triangles. That is, they are congruent triangles. Diagonals are unequal. The two diagonals AC and BD will not be of the same length. They are unequal. Then the diagonals meet at right angles. The diagonals meet at right angles. AC is one diagonal, BD is the other diagonal. They meet at right angles. Also, the longer diagonal here, which is BD, the longer diagonal BD cuts the smaller diagonal AC into two equal pieces. The longer diagonal cuts the smaller diagonal into two equal pieces. That means the longer diagonal bisects the other diagonal, the shorter one. And then these are the differences, when you consider the longer diagonal or the main diagonal and see the two triangles. The two triangles are let me make it more neatly. 1 second. So when you consider the two triangles along the longer diagonal is BD. Okay, the two triangles with BD as a common side or the longer diagonal as a common side are ABD and BCD. This one and this one. These are the two triangles that share a common base BD. They share a common base BD. BD is a side of this triangle. BD is also a side of this triangle. So the triangles ABD and BCD, they have a common side BD. See here? BD. See, BD is here. BD is here also. So when you look at the triangles like that, the two triangles are congruent to each other. But when you consider the triangles, with the shorter diagonal as a common side, when you consider the triangles with the shorter diagonal as a common side, the two triangles are ADC and ABC. These two triangles. ADC is one triangle, ABC is the other triangle. These two triangles they're not identical. They are not identical. They are isosceles triangles because this side is equal to this side and this side is equal to this side. So this triangle is isosceles. This one is also isosceles. So these are the properties of a kite. Trapezium. So we know one pair of opposite sides are parallel. That's why it's called a trapezium. A trapezium is a quadrilateral in which one pair of opposite sides are parallel. The parallel sides are known as the bases of the trapezium. So this is okay. Let me tell you the sides first. So ABCD is a trapezium. AB and BC are the adjacent sides. BC and CD adjacent sides. CD and DA adjacent sides. DA and AB adjacent sides. Now the opposite sides AD and BC are parallel. That's why it's called a trapezium. The opposite sides AD and BC are parallel. Only one pair of opposite sides will be parallel in a trapezium. Those parallel sides are called the bases. The parallel sides are called the bases. Whichever is longer is a longer base, the other one is a shorter base. These two sides, the other two sides are called the legs of a trapezium. The other two sides are called the legs of a trapezium. So this is nothing like leg 1, meaning you can also call this one leg 1. Then this is leg 2. Just to understand, it's not a name given to those sides. It's not that this side is not called leg 1. Just to understand, if you call this one leg 1, then this is leg 2. So which means the parallel sides are called the bases and the non-parallel sides are called the legs. Legs, legs. Legs are the non-parallel sides of a trapezium. Bases, parallel sides of a trapezium. Non-parallel sides is the other pair of opposite sides. The other pair of opposite sides are non-parallel. The other pair of opposite sides will be non-parallel. That's why it's a trapezium. If it's a trapezium, only one pair of opposite sides are parallel. The parallel sides are called the bases and the non-parallel sides are called the legs. Now, E and E is the midpoint of AB. If you don't have this, that's why I'm just hesitating if I should say this or no. Okay. E is the midpoint of AB, F is the midpoint of DC. Then EF is called the median. EF is called the median of the trapezium, ABCD. So the median is a line segment parallel to the bases and divides the legs equally. Divides the legs equally, meaning E and F. E is the midpoint of AB, F is the midpoint of CD. So this line segment joining the midpoints of the non-parallel sides is called the median of the trapezium. The line segment joining the midpoints of the non-parallel sides of a trapezium is called the median of the trapezium. This is a line segment. This one is a line segment. And how do we get this line segment? By joining the midpoints. Midpoints of what? Midpoints of the non-parallel sides. So the line segment joining the midpoints of the non-parallel sides of a trapezium is called the median of the trapezium. So that's what you see here. You can also take the definition I gave you now. Instead of this one, you can also take the definition I just gave you now. I'll send it on WhatsApp later. Okay, so that's about the median. So when it's a trapezium, you have 3 keywords: basis, legs, median. Basis, base or bases are parallel sides. Legs, non-parallel sides. Median, line segment joining the midpoints of the non-parallel sides of a trapezium. So these you can understand, children. Scalene trapezium, you can see the like the definition or the explanation alongside. You can help yourself. So scalene trapezium, isosceles, right trapezium. All right. This I'll leave it to you. Next, parallel. Yes.
Ma'am, is there an equilateral trapezium, ma'am?
3 sides equal.
All the sides equal, from what I get.
No, I'm not sure.
No, right?
No, I'm not. No, I'm not sure. I don't know. I don't think, but yeah, I don't know. I'm not sure. I only know these 3 types of trapezium. Yeah. So parallelogram. So parallelogram, as we understood the definition, both the pairs of opposite sides are parallel. Then it's a parallelogram. So the further properties of a parallelogram: opposite sides will be equal, Opposite sides parallel, we know that's a definition. Opposite sides parallel is a definition. So that we know. Opposite sides equal, opposite angles equal, adjacent angles supplementary, diagonals unequal. Diagonals will not be equal in a parallelogram. In a parallelogram, diagonals are not equal. Adjacent angles are supplementary. So we understood how to identify adjacent angles. Adjacent angles are supplementary. So this one and this one, they are adjacent angles. They are supplementary, meaning they add up to 180 degrees. Two angles that add up to 180 are supplementary angles. Two angles that add up to 90 degrees are complementary angles. If the sum of two angles is 90 degrees, the angles are said to be complementary. If the sum of two angles is 180 degrees, the angles are said to be supplementary. Shivam, what's a supplement of 0 degrees? Shivam, what is a supplement of 0 degrees? Surya? Who can answer this? What is a supplement of 0 degrees?
180 degree.
180 degrees. 180 degrees. And what's the supplement of 180 degrees?
0 degrees.
0 degrees. Because the sum should be 180. The sum should be 180.
Yes, ma'am.
What is the supplement of 10 degrees?
170 degrees.
170 degrees. 170 degrees. What's the complement of 10 degrees?
80 degrees.
80 degrees,
80
ma'am.
degrees. The complement is 80 degrees.
Yes, ma'am.
What is the, what's the complement of 90 degrees?
0 degrees.
0 degrees.
0 degrees.
0 degrees. 0. And what's the complement of 0 degrees?
90 degrees.
90 degrees.
90 degrees. And what is 0 degrees called? It is a 0 angle.
Yes, ma'am.
Where the two arms coincide. The two arms of this angle will coincide. See, like
Yes.
this is an
ma'am.
angle. An angle has two arms. An angle has two arms. Now, AB and AC are the arms of this angle BAC. What you see here is angle BAC. Angle BAC. This the point A is called the vertex of the angle. Point A is called the vertex of the angle. That is the point where the angle is formed, the vertex, where the two arms meet. AB and AC are the two arms. A is called the vertex of the angle. And this is where you mark the angle, whatever, 20 degrees, whatever. So you can see the arms. Somebody's mic is enabled. Disable your mic. You can see the arms distinctly. You can see the arms distinctly. You can make out the arms separately. AC is one arm, AB is the other arm. But when it's a 0 angle, the two arms will coincide. The two arms coincide. So maybe A, B, C, B, C. Angle ABC, but the arms of the angle coincide. That's when it is 0 degrees, and it's called a 0 angle. When the arms spread out, the angle is more than 0 degrees. When the arms don't spread, they coincide on one another, they coincide 0 degree or 0 angle. Okay, so supplementary adds up to 180 degrees, complementary adds up to 90 degrees. And it's only about two angles. Now we cannot say that 40 degrees, some 60 degrees and 80 degrees are supplementary angles, because 40 plus 60 plus 80 is equal to 180 degrees. Therefore, the three angles are supplementary. No. Supplementary angles and complementary angles is only about a pair of angles. Exactly two angles. Two angles are said to be supplementary if their sum is 180 degrees. Two angles are said to be complementary if their sum is 90 degrees. Exactly 2 angles. So properties of a parallelogram: opposite sides equal, opposite angles equal, adjacent angles supplementary, diagonals unequal, diagonals bisect each other. Diagonals bisect each other meaning one diagonal cuts the other diagonal into 2 equal pieces. They cut each other. They bisect each other meaning one cuts the other into 2 equal pieces. And the other cuts the first one into 2 equal pieces. So that means diagonals bisect one another. They bisect each other. The diagonals bisect each other, but the diagonals are not equal. See here, the length of this diagonal, this diagonal say is 20 centimeters, and the length of this diagonal say is 16 centimeters. So this diagonal is cut into 2 equal pieces. So it'll be 10 out here and 10 here. The other diagonal, the length of the other diagonal is 16. So it'll be 8 here and 8 here. The diagonals are not equal. In a parallelogram, diagonals are not equal, but they bisect one another. They cut each other equally. So I repeat, this is 20. So it'll be, this is the midpoint. This will be the midpoint of this diagonal. This will be the midpoint of this diagonal. So it'll be 10 here and 10 here. And for the other diagonal also, the same will be the midpoint. The same will be the midpoint of the other diagonal also. So over 16, it's going to be 8 here and 8 here. That's what is meant by diagonals bisect each other, not at right angles. This is not 90 here. It is not 90. They don't bisect at right angles. It is not 90 degrees here. Diagonals do not bisect the interior angles. So these are the interior angles. 1, 2, 3, 4. These are the interior angles. Now this diagonal, now let me mark the angle. Say this one is 110 degrees. Okay. So this is 110 degrees. Now we know that opposite angles are equal. So this also will be 110. And we know that adjacent angles are supplementary. So this one and this one, they are adjacent angles. They're supplementary. So this has to be 70. Now opposite angles are equal. So this will be 70. So in other words, if you know one angle of a parallelogram, you can find all the others. If you know any one angle of the parallelogram, you can find all the others. Parallelogram. Supposing this is 120 degrees. Only one angle is known to us. Opposite angles are equal. So this is 120. Adjacent angles are supplementary. That is angles next to one another. So this one and this one are adjacent angles. Or you can say this one and this one also. Anything you can take. This one and this one are adjacent angles. So they are supplementary. Adjacent angles are supplementary. So if this is 120, this has to be 60. And if this is 60, this is 60 because the opposite angles are equal. Opposite angles are not supplementary. Opposite angles are equal. Adjacent angles are supplementary. Now, coming to the property or understanding the property, if I call this A, B, C, D, when I connect the points A and C, we get the diagonal AC. Now, this diagonal AC, it goes through, it cuts the angles A and C, right? It passes through the angles A and C. But it doesn't bisect the angles. So this is 120. This full angle is 120. It does not become 60 here and 60 here. It does not. No. It may be 100 here and 20 degrees here. The angle is not bisected. Similarly, here the angle is not bisected. It does not become 60 and 60. It's not cut into 2 equal halves. Bisect meaning 2 equal halves, not 2. 2 equal halves. So the diagonal does not bisect the interior angles. Similarly, this diagonal BD does not bisect angle B and angle D. See, bisecting a side is different from bisecting an angle. This is an angle. This is an angle. This is another angle. Now, this diagonal BD, it runs through the angles, right? See here, BD. It disturbs the angle B. The diagonal BD disturbs angle B and disturbs angle D. Okay. It does not bisect. It does not bisect. So 60 does not become 30, 30. It does not become. It may be 40 here and 20 here. So that's what it is. The diagonals do not bisect the interior angles at the vertices. So that means the diagonal AC does not bisect angle A or C. Diagonal AC does not bisect angle A or angle C. Similarly, the diagonal BD does not bisect angle B or angle D. Bisecting is dividing into two equal angles. So these are the properties of a parallelogram. Rhombus. All properties of a parallelogram hold good for rhombus, but the properties are still more modified here. You'll have something extra, something that distinguishes a rhombus from a parallelogram. Something more special. Okay. So in a parallelogram, opposite sides are equal. In a rhombus, all sides are equal. In both a I'm switching between the two slides, children. I'm switching between the two slides. See, this is properties of a parallelogram. The next one is properties of a rhombus. I am switching between the two slides. So in a parallelogram, opposite sides parallel. In a rhombus also, opposite sides parallel. In a parallelogram, opposite angles equal. Here it cannot be opposite angles unequal. It cannot be that. If opposite angles are equal in a parallelogram, it has to be equal here also. What you find in a parallelogram should be found here. It can be modified. Like in a parallelogram, only opposite sides are equal. But in a rhombus, all sides are equal. All sides equal also means opposite sides are equal, right? So see, that property is modified. In a rhombus, we say all sides are equal. Supposing 10, 10, 10, 10. In a rhombus, all the sides are equal. That also means opposite sides are equal. See, that also means opposite sides are equal. It's modified. All sides are equal. But that does not mean opposite sides are not equal now. When we say all sides are equal, it also means opposite sides are equal. So the property is modified. Opposite sides equal, all sides equal. So that's what it is. That's the difference between a rhombus and a parallelogram. In a parallelogram, only opposite sides are equal. In a rhombus, all the sides are equal. The other things you see here, adjacent angles are supplementary. That is also for a parallelogram. Adjacent angles supplementary. Diagonals unequal. Even in a parallelogram, diagonals are not equal. Diagonals bisect each other. Even in a parallelogram, diagonals bisect each other. In a parallelogram, diagonals are not perpendicular. They don't bisect. They do not meet at right angles. In a parallelogram, here it is not 90 degrees. But in a rhombus, here it is 90 degrees. They meet at right angles. Diagonals meet at right angles. The diagonals, they meet at right angles. So the differences we saw so far, in a parallelogram, opposite sides are equal. In a rhombus, all sides are equal. In a parallelogram, diagonals are unequal. That's an equal, that is a similarity. In a parallelogram, diagonals are unequal. In a rhombus also, diagonals are unequal. In a parallelogram, diagonals bisect each other. Here also diagonals bisect each other. The difference is, in a parallelogram, they only bisect each other, but not at right angles. In a rhombus, diagonals bisect each other at right angles. That is, they meet also at right angles. There they meet, but not at right angles. Here they meet at right angles. So this angle. If this is 90, this is also 90. This is 90. This is also 90. And the most important thing is that the diagonals bisect the interior angles at the vertices. That is, diagonal AC bisects angle A and C. Diagonal BD bisects angle B and D. So if this angle were say 100 degrees, then this also is 100 because opposite angles are equal. Opposite angles are equal. So now because of the diagonal AC, it becomes 50 here and 50 here. This also becomes 50 here and 50 here. Now adjacent angles are supplementary. So if this is 100, this has to be 80. 100 plus 80 is 180. So it becomes 40 here and 40 here. If this is 80, the opposite angle is also 80 here. This also becomes 40 and 40 because of the diagonal going across BD. So here the diagonals bisect the interior angles. So only difference is you can see in a parallelogram, opposite sides equal. In a rhombus, all sides equal. In a parallelogram, diagonals do not bisect at right angles. Here in rhombus, diagonals bisect at right angles. In a parallelogram, the diagonal or the diagonals do not bisect the corner angles. They do not bisect the corner angles. But here in a rhombus, the diagonals, they bisect the corner angles. When I say corner angles, I'm talking about these angles. The corner angles, these angles. Because there are many more angles. No, here also there are angles. We're not talking about these angles. The corner angles, these angles. So these are the differences. Now, rectangle and square. Yeah. Rectangle. So this is a figure which is, very familiar to all of you. We've been seeing this since 3rd or 4th standard, or maybe still younger. Yeah. So in a rectangle. So in a rectangle, opposite sides are equal, opposite sides are parallel. All the 4 angles are right angles. We know this. All the 4 angles are right angles. Diagonals are equal. In a rectangle, diagonals are equal. So far, the two figures we saw, parallelogram and rhombus, diagonals were unequal. They were not equal. Diagonals were not equal. In a rectangle and square, diagonals will be equal. In both a rectangle and square, diagonals will be equal. Okay, so diagonals are equal. So here in a rectangle, diagonals are equal. Diagonals bisect each other, but they are not perpendicular to each other. Here they don't make 90 degrees. Here they don't make not 90. This is not 90, I'm saying. They're not, the diagonals bisect each other. Bisecting is cutting one another into 2 equal pieces. One diagonal cuts the other diagonal into 2 equal pieces. Now here, since the diagonals are equal, this diagonal is equal to this diagonal. These two are equal. So if this one is some 14 centimeters, this also will be 14 because they're equal. So it'll be 7 here, 7 here, 7 here, 7 here. They're cut into 2. See, this is the midpoint of both the diagonals. This is the midpoint of both the diagonals. Diagonals are not perpendicular to each other. It is not 90 degrees here. And diagonals do not bisect the interior angles of the vertices. So this diagonal AC does not bisect angle A or angle C. So this 90 degrees does not become 45, 45 here. It does not. It may be 30 degrees here and 60 degrees here. The total will be 90. But it'll not, they'll not be equal. Similarly, here it will not be 45, 45. So diagonal AC does not bisect angle A or C. Diagonal BD does not bisect angle B or angle D. Square, all sides equal. We know that in a square, all the sides are equal. In a rectangle, only opposite sides are equal. In a square, all sides are equal, like in a rhombus. Like in a rhombus, in a square also, all sides are equal. Opposite sides are parallel because it's a parallelogram. Opposite sides are parallel. All 4 angles are right angles. All these 4 angles. All these 4 angles are right angles. Diagonals are equal. In a rhombus, diagonals are equal. In a square also, diagonals are equal. Where all the four sides are equal, the diagonals also will be equal. You can remember like that. Where all the four sides are equal. So where all the four sides are equal, in a rhombus, all four sides are equal. In a square also, all the four sides are equal. Only in these two, the diagonals also will be equal. So in a rhombus and in a square, diagonals are equal. But in a parallelogram and in a rectangle, since only opposite sides are equal, diagonals will not be equal there. Diagonals are unequal. In a parallelogram and a rectangle, since only opposite sides are equal, diagonals are not equal there. Diagonals are unequal. In a rhombus and in a square, all the sides are equal and diagonals are also equal. You can remember like that. Diagonals bisect each other everywhere. Parallelogram, rhombus, rectangle, square, everywhere diagonals bisect each other. Whether they are perpendicular to each other is what you should watch. So if the diagonals are equal, they will be perpendicular. Sorry, I shouldn't say that because this happens only in a rhombus and square. Okay, let me put it like this. Only where all the sides are equal. In a rhombus and square, all the sides are equal. Only there where all sides are equal, the diagonals also will meet at right angles. So in a rhombus, diagonals meet at right angles. In a square also, the diagonals meet at right angles. In a rhombus, diagonals meet at right angles. In a square, diagonals meet at right angles. So that's what is diagonals are perpendicular to each other. Diagonals bisect each other everywhere. Everywhere the diagonals bisect each other. Everywhere meaning in the four figures we've seen so far. Rhombus, not in kite, not in kite. I'm talking about parallelogram, rhombus, rectangle, square. Parallelogram, rhombus, rectangle, square. In all these four, the diagonals bisect each other. But are the diagonals perpendicular to each other? Yes, they are perpendicular only in a rhombus and in a square. Diagonals are not perpendicular in a parallelogram and in a rectangle. They're not perpendicular. And in the square, the diagonals bisect the interior angles. In a rhombus also, the diagonals bisect the interior angles. In a rhombus, diagonals bisect the interior angles. In a square, also diagonals bisect the interior angles. That is the diagonal AC. The diagonal AC bisects angle A and angle C. The diagonal BD bisects angle B and angle D. So what you'll see is that in a square, all the angles are fixed. There's nothing that you have to find in a square. Whether big or small, whether a square is big or small, the angles are here. Let's take a big square. We'll call it PQRS. PQRS. Diagonal. Okay, to start off, 90, 90, 90, 90. Okay, then let's connect the diagonal PR. Let's connect the diagonal PR. Now the diagonal bisects angle P. It bisects. Now because it goes across a diagonal like this, the angle is disturbed and it's divided equally. So this is 45 degrees and this is 45 degrees. Here also the diagonal bisects angle R. It's 45 here and 45 here. Why 45, 45? Because 45 plus 45 is only 90. This is second, children. Yeah, children. See, 45 is not because we like 45 degrees. Because the whole angle is 90. 90 by 2 is 45 degrees. And when we connect the diagonal QS or SQ, again the angles, the corner angles are disturbed. The corner angles are disturbed. So this angle 90 becomes 45, 45. This one also 45, 45. And since the diagonals are equal and perpendicular to each other, 90, 90, 90, 90. So you see that there is no angle left to be found in a square. These angles are fixed in every square. We have these angles happening. Whether it's a tiny, whether it's a small square or a big square, the angles are fixed. So if a question is like this, given a square ABCD, and if they ask you to find, okay, the measure of this angle, if they call this x, find x is equal to what? X is equal to 45 degrees. It's not that nothing is given. How can we find x? So we may feel like no angle is given. Then how can you find an unknown angle when no angle is given in the figure? You can do that only for a square, not for anything else. For a square, nothing has to be given because every angle is fixed. So the measure of x is 45 degrees. If they mark this y and they ask you what's the value of y, y is 90 degrees because it's 90 here, 90 degrees. If they mark z here, and ask you how much is z, z is 45 degrees. Yeah. Yeah, children, now you have to tell me if the introduction is clear to you. See, it may be a little tricky to remember. That's a different thing. That needs practice. But are you okay with whatever was explained so far? Understood? As I was explaining,
Yeah, ma'am.
did you understand things?
Yes, ma'am.
Yes, ma'am.
Yeah, it's slightly tricky to remember, but you will. With practice, you can remember. It's not difficult. It's very easy. It's very simple to remember. We'll keep, recalling the properties and, classes regularly. So then it becomes easy for you. All of you understand, children?
Yes, ma'am.
Yes, ma'am.
Okay, I can see
Yes, ma'am.
Anantika. Okay. I can see Anantika, Shivam, Lakshana, Gayatri, Surya, Aishwarya, Yarni, and Shriya. See, Harsha is not here now, and also Ariston is not there. Sai Smriti is not there. Saujanya is not there. Right. Gayatri, yeah, she's there. Gayatri, you have your worksheet from tomorrow, is it, Gayatri? Okay, all right. I think that's why your friends are missing today. All right, children. And now, what I'll do is, I'll give you access to my PowerPoint presentation. So you can navigate through the slides and complete the notes. All of you get me?
Yeah.
I'll just
Yeah, ma'am.
yeah, I'll give access to my presentation so that you can navigate. You can use your keyboard to, switch from one slide to the other. I don't have to do that for you, so you can have full control over the presentation and complete the notes. Please stay in the meeting. Please stay in the meeting. I'll just give you the access and let you know. Start writing. Please complete the notes.
Ma'am.
Yeah.
Right now?
Yes, right now. Yes, yes.
Okay, ma'am.
Yeah, just give me a minute. Yeah, children, now check and let me know if my presentation is visible to you and if you have control.
Yes, ma'am.
Yes, ma'am.
Yeah. Yeah, now get started. Right from the first one. So start with, yeah, right from the first slide, children, quadrilaterals. Right from there,
Ma'am,
start writing.
I can't see anything, ma'am.
Ma'am, even I can't see anything.
Ma'am, yeah, ma'am, I can see anything.
Even I can't see it, ma'am. Okay, no problem. How many of you can see my presentation?
Ma'am, this is Aishwarya. I can.
You can. Okay.
Shivam.
Shivam, you also can see the presentation, is it? You have control of the presentation?
Yes, ma'am.
Then who else? That's all? Anindika? Gayatri? Lakshana?
Ma'am, I can't see anything.
What about Shreya?
Me neither, ma'am. I can't see anything.
Surya?
No, ma'am, I can't see
Ma'am, I can change like the screen, like I can change slides.
You're able to change the slides, right?
Yeah, I'm able to.
Yeah, see, there are some who are able to see. The others just leave the meeting and try to rejoin.
It's not working now.
Because if it is, if some of them, even if one person has access to my presentation, that means there should be some error from your end. If nobody is able to get access, then yes, I have to check at my end. Just try to leave the meeting and join.
Ma'am, I tried it, but it's not working, ma'am. Yeah, ma'am. Same for me.
Okay, then let me do one
Yeah.
thing. I'll just 1 second. I don't know.
Ma'am, we're supposed to write down all the slides, right?
Yes, yes. I'll just stop presenting this and I'll come back to my. Somebody's mic is enabled. Disable your mic. Yeah, now is it visible for all?
Yeah, ma'am.
Yeah, then you have to take screenshots, children. Take a screenshot. Let me show you one by one.
Taken, ma'am.
Done, all of you?
Yeah, ma'am.
Taken, ma'am.
No, ma'am.
Okay. No? All right. Next. Yeah, keep acknowledging, no?
Taken, ma'am.
Can I see the quadrilateral, the first slide once? Yes, ma'am, taken.
Taken.
Taken, ma'am.
This is the fourth one.
Taken, ma'am.
Taken, ma'am.
Taken, ma'am.
Taken, ma'am.
Taken. Taken, ma'am.
Taken, ma'am.
Taken, ma'am.
Yeah. So this was a parallelogram, rhombus. We finished rhombus?
Yes, ma'am, we did.
Taken.
No, meaning, yeah, take the screenshot. Yeah, okay. Rectangle.
Taken, ma'am.
Taken, ma'am.
Ma'am, can you go to the previous slide once?
Yeah, sure. 1 minute. Let me just finish off. Yeah, this is square, children.
Yes, ma'am, done.
Taken, ma'am.
Okay, not this. Only till here. Yeah, Anantika, which one do you want?
Yes, ma'am, this one. Taken, ma'am.
Yeah. Start writing, children.
Ma'am, can you show the last slide?
Yeah. This one?
I think that's all, huh?
Yeah, that's all for today's class. Yeah.
Oh, okay, fine. Thank you.
By mistake, by mistake, I went to the next slide. That's all for this class.
Okay, thank you.
Yeah. Okay, I'll come back at 9:30. Now, all of you, 9 of you must stay in the meeting and take pictures of your classwork and put it on WhatsApp for me, children. I need to make sure that all of you have started writing. So if not completing the entire thing, you must have, done as much as possible for 20 minutes. So at the end of the meeting, I want all of you to take pictures of your work, today's work, and share it on WhatsApp with me. I'll come back at 9:30 to, wind up the meeting. Stay in the meeting till then, children.